Thank you all for coming. My name is Henry Keim. I'm a solutions architect at AWS, and I work exclusively with games customers, which is one of the coolest jobs I think you can have at AWS. And today I'm going to be talking a little bit about Unreal Engine and Horde and how you can use AWS and the cloud to really accelerate developer productivity using these tools. And primarily, if you were able to attend the talk yesterday that was given by the folks at Epic who have built Unreal Engine Horde, this will be a good sort of counterpoint to it, and just talking about how you can actually use the cloud in Horde. So a little bit more about me. Before I joined the solutions architecture team at AWS, I was a software engineer at Amazon working on Amazon Luna, which is our cloud gaming platform. And I was working on service level engineering. So I was writing backend services that handled e-commerce and microtransactions within the platform and making sure that those propagated out to games. And about a year and a half, 2 years ago, I decided to switch to this role so that I could work more closely with game studios. Because I really wanted to see what game developers' lives look like, what your day-to-day operations were, and how that kind of compared to my experience in traditional software engineering. So with that in mind, here's a little bit of an agenda for today. I'm going to do a high-level, short overview of game development. No need to tell a bunch of game developers how game development works. Then we'll jump into some of the unique challenges of game development compared to traditional software development. And these are the things that when I switched to this industry were really the most surprising revelations, was realizing how difficult game development is compared to some traditional software development. We'll talk about Unreal Engine Horde. I won't go into a crazy level of detail. If you are looking for a deep dive on Horde, I strongly recommend watching the recording of Ben and Ryan's presentation yesterday on Horde. I'll talk in depth about Horde on AWS and how you can run Horde on AWS, how you can leverage AWS when you are deploying Horde. And then I will close out the presentation talking about an open source project that I've been working on at AWS that we call the Cloud Game Development Toolkit that is intended to make it easier to deploy some of these resources yourself, right? So this is what software development is like, right? You write code, you build code, and then you run code and print money, right? That's how it works, I think. So coming from the traditional software development side of the house and working on services, this was, not my impression, but for the sake of presentation and getting to use stock images, this is what software development looks like. And one thing that's really interesting about traditional software development is a lot of the problems that we face in the game space, things that are really difficult for small studios to get stood up, I had totally taken for granted, right? There are really great communities for common build tools. If you're writing Node.js web applications, there are loads of tutorials and there's great information, good communities, good tool chains. It's easy to go from I have nothing to I have a fully functioning website in a couple of hours. And when I switched to the games industry, I was not surprised, but definitely a little bit taken aback at how frequently I was getting questions from customers. And at the time I covered indies and startup studios that in the traditional software space felt very things that we had solved for, right? Things as simple as, where do I put my project, right? How do I version this thing and share it with people? I'm working with one developer that I met on Discord who lives on the other side of the world, and I just want to work on the project with them. And for some reason, in games, that was really difficult to do in an efficient manner. Also, build times. If I'm building a web app with Node, I can have a complete CI/CD pipeline up and running in a couple of hours. And I came to the game space and I had customers telling me that they were waiting 3.5 hours for builds to finish so that they could test some small change, right? And all that means that iteration is slow. So timelines for building games is just, it's longer, right? Now this is a generalization, and we'll talk a little bit about how the industry has come forward in this space in the last year, 2 years, even 3 years. It's not actually this dire, but coming from the traditional software development side of house, this is what I saw. So I'm going to take a step back, some high-level terminology. So that first question that I kept getting from customers was, how do I version my code? And the industry standard answer was Perforce. Tools for version control and code review, which on the software side, we tend to use Git-based workflows, but in games, Perforce was sort of the de facto answer in that space. Continuous integration and continuous deployment, right? Again, taken for granted in software development, but the process of seamlessly building new versions of my project and getting them out the door to testers or developers. Build tools was the craziest one to me, right? In most software development, if you're working in a Java space or you're working in a Node.js space, the tooling, the runtimes, the testing frameworks are extensive. But in game development, they were very much engine specific. The support was there. There's a great community. I mean, look at Unreal Fest, right? But it was happening very ad hoc, and people had put together tools kind of on their own to give some shape to the noise, right? Make it a little bit easier to work with this stuff. And then Unreal Build Graph, which is, as in Epic's words, a script-based build automation system that features graphs of building blocks common to Unreal Engine projects. So if you work with Unreal Engine at the source level and you are building Unreal Engine projects regularly, this is a pretty familiar term. But if not, this is sort of the de facto scripting model for building Unreal Engine projects. Traditional development pipeline, also probably pretty familiar to most folks, but I took this for granted. Developers submit changes to assets or source code. Those end up in version control, which triggers your CI/CD system to run build jobs. Those jobs could be compilation, they could be cook jobs, etc., right? Those jobs get executed by agents, and you'll notice no AWS icons yet. That is deliberate. Those agents then take those built artifacts and they usually submit them back to some sort of storage. Frequently, for a long time, this was just going back into Perforce, and that's still the case frequently. But there are other options in this space too. You might stick them in a S3 bucket, put a CDN in front of it, whatever you might need, right? There are lots of solutions. And then your playtesters have to download that massive new executable and test this thing, right? And so this very simple pipeline ends up presenting a copious amount of challenges for just the basic game development use cases. The first of those is the projects are just so big, right? Moving this data around and getting it onto build machines is not as simple as it is with Git-based projects, right? If I'm building a web app and I need to build that web app, I can spin up a Docker container, clone the repo down, and that takes seconds, right? Maybe minutes if it's some incredibly large monolithic web app, but really not that long. But in games, the projects are so big that if you needed to sync from source, I'm sure people in this room have done this, pull down the entirety of Unreal Engine 5 from GitHub, it can take like 40 plus minutes, right? And so if you want to take advantage of the same strategies that we use in traditional software development, you have to solve that problem. The projects are just big. The next one is these applications are really powerful, right? Like the hardware that we require to run Unreal Engine is not insignificant. So using dinky little Docker containers on some tiny machine in your garage or in the cloud doesn't work as well or at all. So that just demands that we use more powerful hardware than we do in traditional development. And I'm going to talk about some of these solutions on the right too, but if you look at the first one, for example, right? These are problems that we've faced in the space for a long time, and they haven't gone unsolved. We have started to figure out ways to handle this. So that one up at the top, hydration and caching, rather than having each of your individual build nodes pull down the entire project each time, we start to figure out how we can hydrate those machines more easily with the project, right? We keep copies of things and we mount them onto machines instead of just running a P4 sync or a git pull on every single build job, right? This is not uncommon. People are already doing this. Hardware specialization, right? This is where the cloud starts to differentiate itself. But we realized in the last probably decade even that different steps of a build pipeline in game development process benefit from different types of hardware, right? And that's also a pretty unique thing to the game development space. In software development, you can just kind of throw any machine at most compilation jobs. You know, more powerful is good, but you don't necessarily need to specify between, hey, I need more RAM, I need more CPU for my little build job of my application. But in games, it matters. Configuration is code. So with Docker, or just any sort of containerized runtime, it's easy for me to say, oh, I need these dependencies, and this is where I'm going to build my project, and specify exactly what I want in that container. Spin it up, run my build, get rid of the container. But since we need such powerful hardware to build games, and we already ruled out the container approach, not entirely, still being explored, but you need this big, heavy machine. You need a good way to set that machine up on the fly, right? And this is where tools like Ansible, things like Packer, right? These configuration as code, infrastructure as code, image as code tools become really useful. So there is a solution in this space, but the solution isn't something that most game developers have time or energy that they want to be pouring resources into, right? And then remote compilation is a cool one. And this is where we've said, okay, well, I need this big, heavy, powerful machine, but at the end of the day, I could probably get away with a bunch of smaller ones and distribute the compilation across them. And this is where things like Incredibuild led the way for a long time, and now we have Unreal Build Accelerator, which is also promoting this approach to doing builds, right? You have to compile this big project, you might as well distribute it across a bunch of machines. So the point I'm trying to make here is that these challenges haven't gone unsolved. And so even though I came to the games industry and I took for granted that it was just easy to spin up build pipelines when you were doing software engineering, it was easy to set up version control when you were doing software engineering, and I discovered it wasn't, and there were all of these challenges, I also came to realize over the last year as I started digging into this that there were people in the community who were solving these problems. And whether that was small indie studios that were banging their head against the wall with something for months and then managed to produce this nifty solution to mounting file systems onto build nodes and hydrating them that way, or if it was really large companies like Epic or Riot who were coming in and saying, actually, this is the right way to approach this problem, right? So the point isn't that it's hopeless. The point is there were challenges and there are solutions. And one of those solutions is Unreal Engine Horde, right? And this is the first CI tool that has native integration with Unreal Build Graph, so you don't have to wrap your Unreal Engine commandlets that you call for doing builds in Groovy or a Jenkins file or something else, right? The same script that you use to run Unreal Build tool on your home desktop, your CI system can interpret, right? Horde has a deep understanding of some of those unique challenges that I was calling out on the previous slide, right? There are loads of settings in Horde, and I won't get into them, but you should go dig through the source code at your discretion, which is allowing you to set things like network-mounted file systems that should happen on boot, how you want to scale your instances, how you want to label your instances, all sorts of stuff like that. So Horde is built for all of those challenges that we talked about, and it integrates all of those solutions that we talked about, right? It's a modern application that is scalable and relatively easy to manage. It's not actually that difficult to deploy Horde. And that's probably the biggest takeaway that I would like you to have from this talk, which is the number of times that I've had studios in the last month or 2 months who have come to me, small indie studios who have come to me and said, hey, I'm not sure if Horde is the right fit for me. We're doing Unreal Engine development, but it's pretty easy for me to just spin up Jenkins. I know it, right? And that's fine. If you are super comfortable with Jenkins and you want to keep using Jenkins, go for it. But if you are doing Unreal Engine development and you're interested in trying out Horde, don't be scared of Horde, right? It's not difficult to wield it to your benefit. The other thing I want to call out on this slide, and I am a solutions architect at AWS, but Horde runs seamlessly with a number of other services at AWS, right? And Epic's pretty clear about this in their documentation too. They specify exactly how they run Horde on AWS. They give you detailed information about how many instances of the server run mode for Horde and the worker run mode for Horde, how they've configured their databases to use DocumentDB or Elasticache for Redis. So they've been pretty clear that AWS is treated as a first-party cloud provider for the platform. And I want you to walk away feeling like you can also leverage that functionality. So what are some of the things you can do with Horde on AWS that otherwise might be a little bit trickier? The first one, specialized hardware for compilation and cooking. So I called this out earlier, but we've realized in the last decade or so that different parts of the Unreal Engine build pipeline benefit from different types of compute, right? And AWS provides a very wide array of types of compute. And so the ability to say, okay, well, I want this type of machine, or I want this type of machine, and I want it on the fly to complete this type of job is a massive benefit of running any CI system on AWS. But Horde has such a intimate knowledge of this and the way that auto-scaling groups work on AWS that running it with Horde is something that you can unlock pretty easily, right? This is not complex configuration to get AWS and Horde to play nice. Another huge benefit of running Horde on AWS and just generally building Unreal Engine on AWS is the scale of storage that you can achieve in the cloud, right? So if you were in yesterday's Horde presentation, two of the biggest considerations that Epic had to think about when they were building Horde was how are we going to handle storage and how are we going to handle compute, right? Pretty high level problem, but definitely was an early paradigm, early consideration when building Horde, right? What are our solutions in that space? And so at the application level, they prioritized that. And what I'm suggesting is that at the infrastructure level, you also can prioritize that with the cloud, right? So the problems that you face on the compute front, this type of machine, that type of machine, AWS provides unique solutions for, right? We can easily scale up machines that are meeting particular criteria for particular jobs. But the same is true of storage, right? If you need blob storage, in the case of Horde, right, for managing things like artifacts, logs, there are solutions in that space, right? S3 is probably what we recommend and what Epic would use for those use cases. But things like hydrating build nodes is a entirely different storage need, right? You can't say I'm going to mount S3 onto this EBS or onto this EC2 instance. You need something that has higher I/O. So the solutions are distinct depending on the use case, right? And AWS provides that flexibility in both the storage front and the compute front. Prepare yourselves. So Horde on AWS, right? I tried to keep this both accurate and simplified as much as possible because I don't want anybody to be intimidated by an architecture diagram and a bunch of AWS icons. This is actually pretty digestible. So on the right, you have three main services that I'm going to call out. Amazon Elasticache, Amazon DocumentDB, and Amazon FSx for NetApp ONTAP, right? So I was mentioning picking the right tool for the right job. Well, Horde depends on MongoDB compatible database and a Redis cache. Those are two requirements. And AWS has dedicated services for hosting both of those, regardless of the scale, right? At production, if you have hundreds of developers, or if you are a small team with 5 developers and you want to run Horde, DocDB and Elasticache provide that flexibility. FSx for NetApp ONTAP solves that problem that I was talking about around hydration. So there are loads of cool features in FSx for ONTAP that I could talk about. I Should probably let the NetApp folks talk about those. But one of the big ones is this concept of flex clones. And flex clones are volumes that you can quickly provision off of other volumes. So I'll give you the example in games. I have a Perforce workspace, right, that contains my entire engine code. And I want to run 3 builds of that Perforce workspace off of 3 different change lists, right? Rather than have 3 machines each sync that workspace and run 3 builds, I can have 1 machine sync that workspace and then create a flex clone of it for each of the builders, right? And the cool thing about flex clones is the size of the flex clone is only dependent on files that are written to it, right? So when you read from the flex clone to do the builds, you're not actually accruing more storage. But when you run the UE build process and you're suddenly writing intermediate files all over that workspace, the volume can grow with that build process, right? And then at the end, when you're done, you can get rid of the machine, right? Truly ephemeral build agents. And you can get rid of the storage that you used to hydrate that machine. And that's something that's pretty unique to running these build processes in the cloud, right? Now, this is an idea that's being tested at a number of studios, right? Because this problem is something that a lot of folks face. And I want to call it out here because it's a functionality that you can leverage, or you can say, you know what, I don't think I'm quite ready to bite all that off. I'll just go with machines that turn off and on and not go fully ephemeral. And that's fine, right? Multiple solutions, one provider. In the middle, you'll notice we have this orange box that I call agents, right? Those are your auto-scaling machines that register as agents with Horde, right? And you can leverage spot instances, which are discounted Amazon EC2 machines. When we have spare capacity of a particular type, you can get those machines for cheaper, right? Now, one of the cool things about spot instances, and it's been mentioned a couple times at Unreal Fest already, but Unreal Build Accelerator, which does distributed compilation, can leverage spot instances for that as well, right? Because each of those compilation jobs is short-lived, and you can leverage spot instances in place of traditional on-demand EC2 instances to get cost savings back. And this is one of those things where small indie studios will come up to me and they say, listen, Unreal Build Accelerator is really cool, but it looks expensive. And sure, if you throw 600 cores at a build job, that would be expensive, right? But you don't have to throw 600 cores at a build job, right? You can just, oh, it's crunch time, we want to get a release out, it's Friday. Like, let's spin up 1 or 2 machines, register them as agents, potentially take advantage of spot pricing, get that build done, and then get rid of the machines. You only pay for them while they're on. So you can still use UBA, have the benefit of UBA, of Unreal Build Accelerator, but not have to worry about blowing your budget on 600 cores, right? So this diagram it's cool, right? I hope you think it's cool. I hope you think it's kind of neat. But you might be looking at it and saying, like, that's awesome, but I'm working on a game and I have no idea how I'm going to provision all of that infrastructure. That seems complicated. And I don't like clicking around through the console, or I don't know infrastructure as code tools. So I'm just going to wait around until this is available as a SaaS or something like that, right? And what I want you to take away from this talk is that that's not the case. So, introducing the Cloud Game Development Toolkit. So this is an open source repo that I've been working on for probably 8 months or so. And I'm figuring this stuff out just as much as any other developer in this space as I go, right? Because game development is new to me. But the Cloud Game Development Toolkit is my attempt to say, okay, well, all that stuff is really cool. I want to play with all that stuff. Well, other people might want to come along and also try it out, right? Now, Epic provides the Horde server as a Docker container through their GitHub repository, right? And you can download that, or you can download the Windows installer and boot up Horde on any machine you choose, right? Spin it up at home, boot up a Linux VM and install it on there, right? That's some work, and you can play with it. But you're not mimicking Epic's architecture, right? And there's no reason you shouldn't. Just because you're an indie studio or a mid-sized studio doesn't mean that you can't be running Horde the same way that the biggest studios run Horde, right? Just do it a little bit smaller. And AWS is so flexible that as your studio grows and, oh, now we need more versions of Horde, we need a bigger database, we need a larger cache, those configurations are pretty seamless. You don't have to worry about going out and buying a bigger machine to host Horde, right? And the Cloud Game Development Toolkit is a collection of infrastructure as code templates written in Terraform, image as code templates written in HashiCorp Packer, and Ansible playbooks that you can use ad hoc in pieces to accomplish a lot of the architecture that I just showed you. And the benefit of that is, yeah, maybe today you're not a build engineer. Maybe today you're not an infrastructure engineer. But a lot of the resources are there. We've tried to build pretty extensive documentation. And the objective here is to make this crowdsourced, right? So project tenants, right? So meet developers where they are. It would have been pretty easy to build this project in a variety of ways with a variety of tools. And maybe in the long term, we'll be able to support other infrastructure as code providers and different configuration languages. For example, I worked at Amazon. And when we provision services and manage services, we use the CDK, the Cloud Development Kit, right? And I started this project by writing everything in CDK. And then I started showing it to studios, many of whom actually said, oh my gosh, I have something so similar, but it's internal. And I would be happy to share it, but I'd have to go rip out all of our custom configurations, right? And so I said, well, why don't we just build one centralized place to put all of it? And they said, yeah, I would do that, but I wrote all my configuration in Terraform, and I'm not as familiar with the CDK. And so I said, okay, I'll be flexible. I'll go learn Terraform, and we'll build this thing in Terraform. So the objective was to meet developers where they are, use the tools that build engineers at these studios were already comfortable with. The next one is codify best practices. So I mentioned you could just go install Horde as a Docker container or a Windows installer yourself, but you might just spin it up on a machine, open the security group to the world, have it talk to DocDB over the public internet. All of those things, I wouldn't judge, okay? I wouldn't judge. Maybe a little bit, but I wouldn't judge. So the point of the toolkit is to say, guess what? We at AWS know how to do that kind of stuff pretty well. So here are all of the secure by default practices, right? The IAM roles, the permissions that get assigned to the Horde service and the cluster, they're scoped as limited as possible, right? Security groups are the same deal. So we wanted to be prescriptive, but we also wanted to make sure that developers could come in and say, actually, I don't want to do it that way. I want to run Horde on Kubernetes, or I want to run it on bigger EC2 instance, or I like the Terraform stuff, but I don't like using Packer, or I don't like using Ansible, whatever it is. So rather than give you some black box and say, here, go click a button, here's everything you've ever wanted and more, we tried to keep things as transparent as possible so that you could retain full control of this repository, right? So we promote fork first, or using it as a Git submodule and pulling from it what you see fit. It has three main components: modules, samples, and assets. Modules are Terraform modules. So Unreal Horde is a module. And it provisions everything in that architecture that I was showing you earlier, right? Samples are larger architectures, right? Bigger configurations. So where the Horde module just provisions the Horde service, it also requires inputs. You have to tell it what virtual private cloud you want to put it in, what region it should end up in, which subnets you want things to be deployed in. And samples is our way to show you, hey, you want to provision the Horde module, this is what it looks like. And this is how you integrate it with S3, and this is how you integrate it with things like FSX for ONTAP. This is how you integrate it with S3, right? And then the third category is assets. And these are currently, the primary asset we have are Packer templates. So our objective here is when you want to build an Unreal Engine game, the tool chains that you have to have on that machine are complicated, right? Which version of .NET? Which Visual Studio compilers? All of those dependencies can be a little bit tricky to figure out. Now, they're not hard to do when you download the engine and you're building it locally and you have access to the Visual Studio installer. But when your build machines are spinning up willy-nilly and you have no way to, you don't want to be remoting into them and configuring each of them individually, you need a good way to do that ahead of time, right? And you can't do it at boot because those things take a while. So Packer is a way of building Amazon machine images that contain all of those tools ahead of time. So you run Packer build before you deploy anything. You get an AMI. And currently we have Windows build AMI. We have a couple of Linux build AMIs. And they pre-install a lot of those tools. You can then take that Amazon machine image that you just created and feed it into the Horde module or some of our other modules and have Horde provision those agents on your behalf, right? I'm not going to cover the Ansible playbooks today, but the hope there is, well, there's a lot of stuff that you want to do ahead of time, right? Packaging tools. There are also some things you want to do at boot, right? A good example of that is actually registering a machine with Horde, right? The agent has to tell Horde, I'm ready for work, and you want to keep that agent up to date. So if you package the agent into the AMI, you're not always getting the latest version of the agent. You'd rather download it and register when you start that machine. So this big, beautiful architecture diagram turns into this, right? And this is, for those who aren't familiar with Terraform, this is a Terraform configuration block, right? We specify where the module source is. It's in the same project. You specify the subnets that you want the actual service to run in. We recommend those be private because you don't need to expose the Horde service to the internet. But the load balancers that you provision that sit in front of the service might be external if you want to open it up to particular IPs or a VPN prefix list. But your agents also need to communicate to the Horde server, so you have an internal load balancer. So you're able to really securely structure your networking around Horde so that your agents, which communicate over gRPC, if you watched the talk yesterday, they can get to Horde internally without ever going out of the VPC and back in. And your external developers can get to the web UI or register external agents on-premise machines that you also want to be controlled by Horde. Those can come in from the internet, right? And all of these things can be turned off and on. You can set subnets, right? The point is that it's configurable, but we provide some defaults that are pretty readable, right? Now, there is one that I want to call out here. GitHub credentials secret ARN, which is an ugly name for a variable, but an accurate one. The Horde Docker container that is published by Epic is available in the Epic Games GitHub organization. And to have access to that container, you have to join the Epic Games GitHub organization. And so the way that the Horde module actually provisions that container is by the AWS Elastic Container Service behind the scenes is fetching the container directly from Epic. So if you want to modify Horde and build your own version of the Horde server, which is not difficult to do, You could pop into the module, strip this stuff out, and replace the image with your own, right? You don't have to pull it directly from Epic. But for the sake of quick start, and like you just want to play with this thing, all you got to do is specify some GitHub credentials for the module to use, right? So usually a username and a personal access token. If you have questions about that, that stuff's in the documentation. But I do want to call it out. We're not redistributing Horde here, right? Horde is application level, Epic's domain, and very cool, but not what we're redistributing here. What we're showing you is this is how you run this thing at prod. And when I say run it at prod, I don't mean run it at prod for like 1,000 people. I mean run it at prod for 5 people, 70 people, right? Whatever your scale is at this moment. So our Unreal Engine Horde module follows Epic Games' internal deployment suggestions, right? DocumentDB, Elasticache, all that good stuff. It can also configure the Horde server in both server mode and worker mode. We're working on some improvements in that space. But it will be configurable with the Horde settings that are also exposed, right? And it does that through environment variables by interacting with the application. We do TLS termination for Horde at the application load balancer level, right? So the ALB communicates with Horde over unencrypted HTTP, and you communicate with the load balancer over HTTPS. And security groups lock everything down. So the ALBs are only able to talk to the service is only able to take inbound connections from the ALBs. The only way in and out is through HTTPS encrypted load balancing. We use autoscaling groups for spinning up the build machines. And we use AWS Systems Manager for applying the Ansible playbooks when the machines start up so that they can register with the Horde service, right? So all of these intricacies, right? Go play with Horde. It's really cool. Okay, you start going to play with Horde, and every machine you're configuring individually, right? That works for a little bit. That works for testing. But as soon as you want to start actually using these tools for what they are, tools, you'll need to start adopting some of these practices, right? So what else is in the toolkit, right? Today I've talked about Horde, but there's other stuff in there. We have modules for deploying Perforce Helix Core, Helix Swarm, and the Helix Authentication Service, which is used to integrate your third-party identity provider with other Helix workloads like Swarm and Helix Core. I mentioned them earlier, but those Packer templates for spinning up your build machines. And then just general documentation, right? That's an area where we are really actively pushing changes, right? We want to get the documentation to a point where you can come in, and even if you're not quite ready to bite all of this off, you can just read up on the AWS side how you would provision and manage this infrastructure. And what's next, right? So this first bullet, we're still scoping, whether it's, we have a cloud-derived data cache module in the works. There's also all of the updates this week around Zen servers that will probably end up in this module, in this toolkit. The UGS metadata server. There was an announcement a couple days ago that the Unreal Build Accelerator cache server will be announced at some point, and we'll try and support that as well. So our objective is to just sort of track fun updates, right? And as those things come out, we want to make it as easy as possible for you to deploy them and play with them. This last bullet's kind of cool, or second to last. The guidance on building for Windows platforms with Amazon Linux machines using Wine. So swing by the booth, the AWS booth downstairs on the expo floor, and I'll show you this actually, which is we're doing Windows compilations of the UE editor using a lot of cores, but they're Linux machines and they're running Wine, and we're getting editor builds down to 10 minutes or less. I'm sure we could get it faster if we threw more cores at the problem. So the ask is to help us build this. I would say that probably upwards of 70% of the stuff that I put in the toolkit, I learned from studios who were already solving these problems. And that's a good thing. That's not, that's something that we should lean into, right? Getting this stuff working is not proprietary technology. It's not what you're trying to do. You're trying to build games, right? Getting the tools up and running is like, that's, step one stuff that you want to get out of the way, right? And generally, people are willing to share this. So our request is that you hop in this repo. You'll notice it has a alpha release tag. That is very deliberate. But I will say that the modules and the samples work, right? You might need to consult some documentation. Again, this isn't click button deployments, but we're active in there. If you have questions of me, I will respond. If you raise issues, I will comment on them. I will triage them. So the hope here is to build a community of folks who make it easier to build games, specifically Unreal Engine games, but really, if you're using a different engine, that also works, on AWS, right? We don't want AWS to be this untouchable cloud resource that you can't use unless you're huge. If you're an indie studio, you can also unlock a lot of acceleration by using these tools. There's a QR code. You can scan it if you want. It'll take you to our docs pages right now, which are also hosted through GitHub. But yeah, give the repo a star, please, and follow us. Let us know if you'd like to see stuff done differently. One of the biggest areas we imagine there will be contribution is in the Packer templates, right? Studios have loads of neat tricks and tools for adding caches. We have Packer templates that add things like Octobuild, which is a UE-specific caching tool. So if you see stuff in there that you're like, hang on a second, I don't think that's right, let us know. And raise feature requests, raise bugs. We have pretty comprehensive docs, and we're trying to work on our GitHub hygiene. So yeah, that's my talk. Thank you.